Okay, so today we're going to start looking at Piecewise. Is two or more graphs graphed on the same grid, but your grid is broken up into sections, or pieces, hence the name. So if you take a look at this one, this first one has two pieces. One part of this graph will follow x plus 5, y equals x plus 5. So it's just a straight line, right? It has a y-intercept of 5 and a slope of 1. The thing about it, though, is you're only going to draw that line if x is less than -2. So, if I look at my other branch, you'll see that it only exists if x is greater than or equal to -2. So basically, I'm taking my grid and I'm breaking it up into two parts. One part that's less than -2 and one part that's greater than or equal to -2. So one thing that I like to do, and this is not part of the graph, so you don't have to do this, but I find it very helpful, is I draw myself just a dotted line at where my grid is getting divided, okay? And I'm talking about the x's being -2. So I'm basically going to, I start off at -2, x equals -2, and I just draw myself a dotted line, just to help myself understand one graph is going to live on the left-hand side of this line. One graph is going to live on the right-hand side of this line. Okay? So that's what this means. And they don't even actually have to be the same number, right? Because I can break my grid up into as many pieces as I want. But usually you'll see that it's the same number. So I'm going to have something that's happening to the left, which is when x is less than -2. And then I'm going to have this happening on the right, greater than or equal to -2. Does that make sense so far? Alright, so basically there's two ways to do this. Sometimes I have kids just draw the two and then they look and they erase part of the line where it shouldn't belong. I actually think that it's easier if you just go ahead and take this number, plug it into this function, and then follow your slope. So in other words, at -2, right? If I plug it into this top function, what is -2 plus 5? 3, right? So when I plugged in -2, I got out a 3. 1, 2, 3. Now, see, because that is a less than, I have to put an open dot at that spot. So -2, 3, I put an open dot. Because this top line doesn't actually exist at -2. It only exists when x is less than -2. Are you with me so far? Have I lost anybody? Now, this line, this top part right here, is only going to exist on the left-hand side because that's where the x's are less than 2. This is where x is less than -2, right? Over here. So this is my dividing line. I'm going to graph this x plus 5 only over here. It's not going to live over here because it doesn't exist there. When I get past this line, I jump to this one. So anyway, how do you graph it backwards? Well, what's my slope? My slope is 1, right? But if I'm going backwards, normally I would go up 1 over 1, up 1 over 1, up 1 over 1, right? But I want to go backwards, so what should I do instead?
Down 1 over 1.
Down 1, back 1, down 1, back 1, down 1, back 1. That's pretty much it, right? So I'm just going to connect the dots this way. This line would continue forever in this direction. If I had let it cross the y-axis, it would have crossed at 5, right? But I don't need it because once I hop over this red divided line, this top portion doesn't exist anymore. Now I'm right back here. So once I go past -2, I draw this line. Well, what does this line look like? It's a y equals -4, right? So it's horizontal. So now this one does exist when x is equal to -2. So I'm going to put a solid dot at -4.
First dot's supposed to be open.
It is. I don't know if you can tell. I tried. I should have made it bigger, but it is open. So, and actually, let me try and use pink. That might show better that it's different. So this line just continues forever in that direction.
Why is the other line negative? Like how it goes down?
Why does it do what?
Why does it go down instead of up? Like
This is just a flat line, right? That's not a slope. This is just the line y equals -4.
What about the other one though?
This one has a slope of +1, right?
Yeah.
So isn't the slope of this line +1? Didn't I go up 1/1?
Oh, yeah.
But you can't go past this line, so we have to do the reverse. You get what I'm saying? So you do the opposite of what you normally would do. I normally go up 1 to the right 1, up 1 to the right 1, but when I have to go backwards, I'm going to go down and left, down and left.
And then when it's negative, it would go up.
Right, right. So we'll see an example of that in the next one. And that's it. So that's my graph. So I have graphed this function, which was split into two pieces. Part of it existed when x was less than -2, and part of it exists when x is greater than or equal to 2. Just a couple of things. Remember that when things are functions, remember that they're supposed to pass the vertical line test? Do you remember that? Does my graph pass the vertical line test? It does. Now, what happens exactly right here? Because one dot is open and one dot is closed, it's fine. What you can never, ever, ever have is two dots on top of each other that are both closed. Because then it's like, okay, when x is this value, well, which is it? Is it the top one or the bottom one? So you're never allowed to have two closed dots on top of each other. You're never allowed to have any portion of the graph on top of each other if it's going to be a function, right? So this one is perfectly fine.
Two open circles is fine.
2 open circles is fine also.
But isn't that just like having a gap?
Right.
Can you do that?
Mm-hmm. You can. Okay. Did this kind of make sense? Let's see if we get it with our second one. So the second one, so this time this function again breaks into two parts, but this time my whole graph is getting split at 1. So the top graph is only going to exist when x is less than 1. The bottom graph will only exist when x is greater than or equal to 1. So again, I'm going to start off by dividing my grid into the two parts, less than 1 and greater than 1. So I go ahead and I put a dotted line at 1. This is not part of the graph, so if you leave this out, you will not, there's no penalty for that. It's just sort of to help me know where I'm going. So I have something happening to the left of this red line, something happening to the right. Okay, so here's where I have to use a little bit of brain power to figure out where I even start, okay? If I take my breaking point, which is 1, and I plug it into the function, right? 2 times 1 plus 1, what comes out? 3. So 1 comma 3 is my starting point. Oh wait, 1 comma 3. Now, do I put an open dot or a closed dot for this one? Open, because it doesn't actually exist when x is 1. It's only when x is less than 1. So I'm going to put a open dot at 1 comma 3. 1, 2, 3. I'll make this one a little bit bigger so we're clear that it's open. And now, because that's a point on my line, I just have to follow the slope. You don't have to worry about the y-intercept. It's going to cross at that point. Well, I mean, I guess you could put it if you wanted. Right? Because I know it is going to cross at 1. So normally to follow my slope, I would go up 2 to the right 1. So instead, I'm going to go down 2 to the left 1, which there's my y-intercept anyway. Down 2 to the left 1, down 2 to the left 1. And there I have it. So there's one part of my graph. There's the portion that exists when x is less than 1. And then I just do the same thing for the bottom one. This one's a little bit different because in the last example, I just had -4, so I just graphed -4. But here I'm going to take my answer, or my dividing point of 1, plug it in, give myself a starting point, and then just follow the slope. So if I plug in 1, negative 2 plus 3 gives me 1. So my starting point is at 1, 1. And should I use an open or closed line for that? Close this time. And then just follow my slope. It's easier on the right-hand side because it is just what it tells you to do, right? Down 2 over 1. So from that point, I just go down 2 over 1, down 2 over 1. And connect my dots, and I should be all set. Does this thing pass the vertical line test? It does, right? On here, and then when they're the 2 dots on top of each other, one's open, one's closed, that's fine. I just can't have 2 closed on top of each other, and then that proceeds. When kids mess up these graphs, this is what I see all the time. They'll do something like this. They put them both the same way. So they might have their dividing line, right? They have the dividing line, and then they'll have the pink line the same way. So they might have something like this. And then they mess up the purple line, and they put the purple line this way. So they'll think that that's the right answer. But if they just stop and ask themselves, does this pass the vertical line test? No, and these are supposed to be functions. So this cannot be correct. If you have the lines passing over each other, those are not functions. So you can't have graphed it correctly. Does that make sense? I'll take your silence as a yes. Okay.